These are the solutions to question number 2 from the 2014 linear algebra examination. For part A, we want to determine whether these two lines intersect and then find the shortest distance from the point 1, 0, minus 4 to the line L2. And for part B, we want to find the Cartesian equation of a plane containing these 3 points. So for part A, here's our line L1, here's the line L2. We write these in parametric form, so now we want to show where the lines meet. So here is our line L1 has to equal L2 at some point for R and S. So we equate the first components to get this equation, we equate the second components to get this equation, and we equate the third components to get this equation. Now if there is a solution, these equations will be consistent. So you can see from here, equation 2 gives us R as a half, and equation 3 with R as a half gives us S as a half. But if we put those back into equation 1, then this does not give a contradiction. So everything is fine. So the lines do meet at when R is a half and S is a half. So therefore, the points meet. The lines meet at the point x is 3/2, y is 0, and z is 3/2. So that's just satisfying these equations. To find the shortest distance from the point 1, 0, minus 4 to the line L2, we proceed as follows. So we suppose that x is perpendicular point on the line. So here is our line L2, which is written in this form. So it's 1 plus s, 0, and then 1 plus s. So that is the vector equation of the line, and we assume that x is perpendicular point on that line. So the vector ax is given by s, 0, and 5 plus s. So remember, the vector ax is the vector x minus a. So the vector x minus a is given by s, 0, and 5 plus s. So the vector is perpendicular to the line, so we now take the dot product of this with the 1, 0, 1. Then we get this equation here. So if we solve this equation, then we get s is equal to minus 5/2. And then if we substitute minus 5/2 into this equation, into this equation, so ax is this vector. So to find the length of this vector, we just use a Euclidean norm. So that's the square root of 25/2. And that completes the solutions. And then for 2 part B, so for 2 part B, we have these 3 points, and we want to know the equation of the plane containing those 3 points. So using these 3 points, we can find 2 vectors in the plane. So for example, A is equal to this vector, minus 2, 1, minus 1. So I think I've done this vector minus this vector. So this vector minus this vector gives us A. And then I think it was this vector minus this vector gives us the vector B. So these are now 2 vectors lying in the plane. So if we find the norm, we just cross these 2 vectors. So A cross B will give us a norm to the plane. And if you work out this determinant, we get this vector. So this is the normal to the plane. So these are the coefficients of the plane. So we get minus 6x minus 15y minus 3z is equal to some p. So then we simply substitute for x, y, and z from any of these points to find the point p. And you can see in this case that p is minus 51. So this is the Cartesian equation of the plane containing these 3 points. And that does conclude the solutions for question number 2.